All right, well, we measured temperature, we measured density, and we've got all these measurements, and we know how to do sig-fig calculations. Well, let's put that together. What if I want to change one unit from another? Okay, what if I want to change grams and kilograms? Okay, what if I want to change liters to centiliters? What if I want to do that? What if I want to change the units? Because we have to have the same units if we're going to add things together, right? We know that, apples to apples. So I got to convert. Now, you guys familiar with conversions? Yeah. Oh, yay, we are familiar. Awesome. Okay, because, we can use this conversion method, dimensional analysis. You might have heard that term that way. The Science Tutor Center will do some dimensional analysis clinics to help you with this. But this is a method we have to get down. We're going to use this all the way through, constantly. So we really, really, really need to nail down dimensional analysis so we can do stoichiometry and other additional things that we're going to do with it. So this is one of our building blocks. So it's very important that you nail this down. So a lot of us are familiar with it. We use it. What's the purpose? The purpose is to convert one unit to a different unit. And that works great in chemistry. You might have done that in physics. If you're cooking in the kitchen, you can use dimensional analysis. I do that all the time when I'm doubling or tripling recipe and I'm going from teaspoons to tablespoons or, cups. And I bring out the dimensional analysis, and my daughter's like, "Oh, Mother." But it works great. It works great. You know how sometimes when you're converting meters to kilometers, you sort of move the decimal the wrong way? It happens a lot, right? Well, if you use this method, you won't have that problem anymore. You'll always get it right. So that's the neat thing about this. It's got built-in checks for you. So let's talk about this dimensional analysis. Well, what is dimensional analysis? It's the ability to convert between one unit and another. And what are we going to use? We're going to use what's called a conversion factor. So you have one unit and you have the other. How are we going to relate the two together? Conversion factor. All right, so let's talk about what's a conversion factor. You have to be able to generate these necessary conversion factors. Well, what is it? It's a ratio. It's a ratio of one number and unit to another number and unit. Now, conversion factors has to have the number. And can we forget the units? No, we have to have numbers and units. Numbers and units. Now, these conversion factors, okay, we said they're a ratio. You have to have numbers and units. Where does it come from? It comes from true relationships. A true and valid relationship. What's a true and valid relationship? It's when you equate things together, they equal each other, and they have different units. For example, 1 foot equals how many inches? 12 inches, right? We know that. These are different units, but we know this to be this equal. That's a true and valid relationship. 1 foot equals 12 inches. Give me some more. 1 inch is 2.54 centimeters. Give me another one. Okay, 1 milliliter equals 1 cubic centimeter. Very good. How many days in a week? 7 days is 1 week. Okay, so you see how we're getting these true and valid relationships? It's things you know to be equal, and they have different units. These are true and valid relationships. This is what we use to make a conversion factor. Okay, so now we have these relationships. How are we going to get the conversion factor? It's a ratio. Let's take foot and inches. A ratio would be 1 foot divided by 12 inches. But you know what? I could do it the other way too, couldn't I? 12 inches divided by 1 foot. So for every true and valid relationship, how many conversion factors do you get? 2, always 2. Why? You're like, why do we need 2? Well, one of them converts feet to inches, and the other one does inches to feet. So you always need 2. All right, well, let's write some more conversion factors. How would you write a conversion factor for inches and centimeters? 1 inch. Okay, 2.54 centimeters. Or Uh-huh. All right. Do you see how we got that? Let's do weeks and days. What would it be? Let's see. Let's do days in a week. How would that conversion factor be? 7 days divided by 1 week, or 1 week divided by 7 days. Awesome. All right, so now you know how to get conversion factors. What are we going to do with them? Now that we have them, what do we do with them? We multiply with conversion factors. You multiply and divide. So now you can multiply and divide numbers. We know how to multiply and divide numbers. But can we really multiply and divide units? Yes. What's a centimeter times a centimeter? Centimeter squared. What's a centimeter times a centimeter times a centimeter? Centimeters cubed. What's a centimeter divided by a centimeter? No unit. It's number 1. It's no unit. They cancel. In other words, we say these cancel. So when you divide the words, you cancel the units. Okay, so dividing words, dividing our units, same units, dividing the same units, we say we are canceling. They're canceling out. We say canceling out the units. In other words, we end up with no units. Okay? So we can multiply and divide numbers, and we can multiply and divide words, can't we? All right, so that's how we're going to do conversion factors. Now, where did we say conversion factors come from? They come from where? A relationship. What about the relationship? What are we supposed to? A true relationship, and we divide out the ratio? Okay. That's how we get conversion factors. From true and valid relationships, and you divide them out. And then once we get the conversion factor, we multiply with it. And that is dimensional analysis. But the cool thing about dimensional analysis is that it helps us get the right conversions going. So let's just practice that. Let's take days and weeks. All right, let's say we have, 14 days. 14 days. And I want to know, hey, how many weeks is that? All right, now you think, how many weeks is that? Now, I have 1 unit and I want to change to another unit, so I'm supposed to use what? A conversion factor? Okay, this conversion factor needs to relate these 2 units. And it is going to be 7 days in a week. And then I'm going to change that to a conversion factor, right? Okay, so that's what you do. You have 2 units. You come up with a conversion factor. But the problem is I have 2 conversion factors. Oh, which one do I use? Ooh, I want to change days to weeks. That means I have to cancel out the days. And remember, the only way we said we're going to cancel out the words is if we do what with it? Divide. So I got to use the one that divides by days. Yeah, it's this one. All right, so let's put that in here. So I'm going to multiply, and I'm going to say 1 week divided by 7 days. Okay, now these are multiplied by the fraction because I'm dividing by days, so these cancel, and I'm left with weeks, so my answer becomes 2 weeks. Well, what if I use the other conversion factor? This is where you always watch the units. If I said 7 days divided by 1 week, wow, let's multiply this out. I got days times days. What does that give me? Days squared divided by a week? Okay, well that does not make any sense, does it? So this has a built-in method to make sure you're going in the right direction with your conversions. Okay, so the units must cancel. So we multiply them together and the units must cancel. So how do we do this? We identify the given unit for the days, come up with the conversion factor where the units are canceling. That's all there is to it. So let's see, you guys could do this one. Let's try one where we're going from inches to centimeters. Okay, so we have our 2 conversion factors. So let's see if you can do this one really quick here. Convert 8.5 inches into centimeters. Okay, see if you can figure that out. Set it up. Okay, so you got the 8.5 inches, and you want to change that to centimeters so you know what unit has to cancel out, right? Which one do you want to get rid of? You want to get rid of the inches. So you know which one units you're going to use, aren't you? Okay, so you know which conversion factor we're going to use? We got two conversion factors up there on the board. Which one is the right one to use? Oh, awesome. I like those PowerPoints. I know, that's fun. How are we guys doing back here? Good? Okay, so it looks like we got it. Now turn to your neighbor and double check your answers. And talk about it. Did you get the right answer? Well, and we watched our sig figs, didn't we? Whenever we do calculations, are we always going to be thinking sig figs? Yes. Every single calculation you do, you're going to count and pay attention to sig figs. On every homework problem, on every class problem, on every test problem, every single one. Now, there might be a couple answers on that exam that are the same, but they differ in the number of sig figs. You're going to know which one to choose, right? Yeah, you got to pay attention to those sig figs. Watch that dimensional analysis.
Okay, so whenever we write it like this, should we count the sig figs here also? Or
Nope.
No,
Because this is an exact number. It's 1. It has an infinite number of sig figs and decimals. All right, so what did you guys get for your answer? 21.6? 21.6 what? Centimeters. Okay, so the unit that you used was what units? I mean, what conversion factor? 2.54 centimeters on top and 1 inch on the bottom, so that these inches can cancel, right? Okay, we can write it like that, but I'm going to show you another way that I like to write this, especially when we get going with lots of them. It's a little bit easier. I start with my unit, 8.5 inches my started, and then I draw a line, and then I do these hash marks. Okay, and if I had more conversions, I'd do more hash marks. And what I'm going to do is I'm going to write in 2.54 centimeters on top and the 1 inch on the bottom. Okay, so I'm drawing the lines like this. If it's side by side, that's multiply. If it's top and bottom, it's divided. Okay, so I'm going to do it this way just because it's faster than writing that time symbol in parentheses and all of that. Now you got to remember to keep the units. Now the sig figs was 21.6. Oh, let's count sig figs. When multiplying and dividing, answer must be least number of sig figs. How many sig figs? 8.5. 3 because we have decimal, right? 3. How many here? 3. How many here? That's an exact number, isn't it? It's always 1 inch. It can't be 1.8 inches, right? It's 1.000000. Remember we talked about it has an infinite number of sig figs? So this is an exact counted number, and it has an infinite number of sig figs. So the least number would be 3, infinite. What's the least number? 3. That's why my answer has 3 sig figs. Okay? So when you're doing this, you're not going to pick 1 sig fig, are you? No, because that has an infinite number. So 3 is the least amount. So it's 3. All right, does that make sense? Okay, super. Let's do some more. Woo, we're having such fun with this one. All right, well, we just did 1 conversion. Oh, that was so easy. My gosh, just 1. Let's add to that. Let's do 4,338 milligrams, and I'm going to change that to kilograms. Okay, thinking about that table that I memorized, there's no conversion between milligrams and kilograms on that table. The only thing I remember is what? Milligrams to what? Grams, and then grams to kilograms. Didn't we have that on the table? Okay, so when you're doing something like this, and you're like, I don't know that conversion factor, then you might need multiple conversion factors, and you can always take it to the base unit, which in this case is grams. So I'm going to do that. So I'm going to go from milligrams, and I'm going to change that to grams, and then change that to kilograms. So in this case, we're doing more than 1 conversion factor. And when we do that, we write what's called a road map. A road map helps us understand what the units are that we're going to change from one to the other. And every time I have this symbol, this means I need a conversion factor. Okay, so for every symbol, I need a conversion factor like this. So what I'm saying is milligrams, conversion factor to change it to grams, another conversion factor to change it from grams to kilograms. Okay, so let's set this one up. All right, I've got milligrams, and I want to change it to grams. So think about that valid relationship. Okay, so you guys remember that relationship? 1 gram is 1,000 milligrams. Okay, that's the relationship. Now, what unit, let's do units first, what has to go on the bottom? Milligrams. So do you see why we're going to put the 1,000 milligrams on the bottom? It has to. Why does the 1,000 milligrams have to go on the bottom? That way they cancel. And then the 1 gram goes on top. Okay, now that one's done. Let's go again. What do I have on top? Grams. And what am I trying to get to again? Okay. Oh, wow. What was that relationship? 1,000 grams, 1 kilogram. Okay, so I've got grams on top. What do you think I have to put on the bottom? 1,000 grams. It has to be grams, doesn't it? And then what goes on top? Kilogram. Okay, so the units cancel. Whatever's left, that's what your answer comes out to be in. So now let's count sig figs. How many sig figs do I have here? 4. How many sig figs here? Infinite, infinite. How many here? Infinite, infinite. Isn't this an exact counted number? Don't we define 1,000 milligrams are in a gram? We didn't say 1,000.2, did we? No, it's exactly 1,000. No more, no less. We didn't say 999.9. No, it's 1,000 is exactly, it's an exact number. 1,000 milligrams in a gram. Do you see how that's an exact counted number? All right. So how many sig figs does this one have? Infinite. 1 kilogram is infinite. And 1,000 grams? Infinite. Perfect. So I've got 4, infinite, 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 infinite. How many should I have? 4. So I'd have 4. And we can put this in scientific notation because it's a bigger number. Or I should say more decimals. 10 to the minus 3 kilograms. All right, that's a roadmap. And that's how we do multiple conversions. Well, let's practice doing roadmaps a little bit more so we can get some ideas of the concept here. All right, let's say I want to go from century to seconds. Let's go from a century to seconds. All right, so we don't have a conversion factor between century and seconds, do we? No. So are we going to have to step it through some units? All right, so let's talk about what those units are going to be. All right, so I'm starting off with century. If you were to do your roadmap, what would you say? Century convert to what? Years. Okay, do you know that unit? Yeah. Okay. And then you're at years. Now what are you going to go to? Day. We're not doing leap year. Okay. Years and months, we could do that. Okay, but now what? Days and months are not quite that's not a, 30, some months are 30, 31. Maybe I don't want to do months. Maybe I want to go weeks instead. Okay, so let's do weeks. There's 52 weeks in a year. And then what? Days. And then what? Hours. Then what? Minutes. Then what? Seconds. Perfect. Okay, that's one. What's another one? Could we do another one? What if I don't know the conversion factor between a century and a year? Maybe I only know century and a decade. I could do that. Sure, I could do that. And then I could go decades to what? Years? Okay. And then I could go to weeks. Or if we don't take into account leap year, maybe I could go from years right to days, couldn't I? And then we could do the same thing. Days, hours, minutes, seconds. Okay. You see how that works? All right. Well, maybe I might do this. I might say century, and then I might go to decade, and then I might go to years, then I might go back to decade, then I might go back to years, and then maybe days, and then again hours, minutes, seconds. Well, maybe this one, I know how many seconds there are in an hour, so maybe I don't need to do that. Maybe I could go directly from hours to seconds because I know that conversion factor. I could do that. So are any one of these particularly wrong? No. Could I use any one of these? Yes. That's the thing about these conversions. There's not always an exact one way to do it. Some of you might know more conversion factors than another. Your roadmap may look slightly different from someone else's. But the key point is that you must have true and valid relationships with each conversion. Each conversion has to have a true and valid relationship. Can't be making up stuff. Okay, and if so, and your units cancel, then you can use any one of them. Now, some of them are directly and shorter. It's like a road map. You're going from here to Dallas. Can we take different roads to get there? Yeah. Sure. Some of us might go directly there. Others might take the scenic route. And some of us, decades to years, back to decades, back to years, some of us might want to drive around the block a few times. That's okay. All right, as long as we get there and the units are correct. Okay, so that's the idea of road maps. So when you do these big long conversions, write your road map out so you can get an idea of where you're going, and it'll help you as you step it through. Now, what conversion factors are we going to need for dimensional analysis? Don't be Googling up different conversion factors. Okay, don't Google those things because you're not going to be able to Google conversion factors on the exam. So what conversion factors, can I borrow your book? What conversion factors are we going to need? All the conversion factors that you need for this course, exam, homework, and everything else, is going to be in the back of your textbook where it says useful conversion factors and relationships. Okay? This is going to be provided to you on the exam. This is all you need. So when you're working your homework problems and you're working on things and you're practicing, come to here and use these ones. Don't Google up other ones. Don't Google other ones. Just use these for those are your conversion factors. Okay, so that's the only ones you're going to need, those conversion factors. Thank you. Okay, so that's roadmaps. So we can do simple conversions. We can do lengthy conversions. Let's do it. That was so easy, right? Was this all easy? Okay, let's do something a little bit more complex. We're going to do this one, and we're going to do one with squares and cubes. All right, we got this. This is so easy. Let's convert 3.73 times 10 to the 8 cubic kilometers. So if it's cubed, it means volume, right? We're going to convert that to liters. Let's do our roadmap. How would we do that? Cubic kilometers, and you have liters. Well, how are you going to convert cubic something to liters? You guys remember? Okay, so we know that cubic decimeters is a liter. Okay, so I got cubic decimeters here. We also could do cubic centimeters as a milliliter, couldn't we? And then couldn't I go milliliters to liters? Sure. Well, we'll go ahead and go with cubic decimeters. All right, cubic decimeters I can convert to liters. Now, how about kilometers to decimeters? How can I do that? Meters, I can go through meters, couldn't I? Okay, I can go through meters. Now, they have to be cubed, though. Now, here's where the problem is. I don't know the relationship between cubic kilometers and cubic meters. But I do know the relationship is 1,000. I know the relationship kilometers and meters, right? 1 kilometer is 1,000 meters. I know that. But how would I get the cubed one? Well, I can cube both sides. Because is this an equal sign? It's an equation, right? If I do something to one side, I can do it to the other. So if I cube this and I cube this, then cube, remember, means not times 3. Okay, it just means 1 kilometer times 1 kilometer times 1 kilometer. Multiply the numbers, you get 1. Multiply the letters, you get cubic is equal to 1,000 meters times 1,000 meters times 1,000 meters. So what does that equal? 1 times 10 to the what? 9. 9. 1 times 10 to the 9 meters what? Cubed. This is your true and valid relationship. This is what you're going to use to get that conversion factor. Okay? Does that make sense? All right, now we got to do the other one. Meters and decimeters. How are we going to do that one? Well, do you know meters and decimeters? What is it? 1 meter, 10 decimeters, decade, kind of thing, 10 decimeters. Can you get the cubed one? Yeah, how would you do that? Cube both sides. Now, if you have this true relationship, now can I set up my units so that they cancel? I can, can't I? You know which one goes on the bottom, don't you? Yeah. Okay. I want you to derive the relationship you're going to use for cubic meters and cubic decimeters, and then I want you to set up this conversion. All right, see if you can do it. And if you're not sure where to go or how to start, check with your neighbor. Make sure your units cancel. You have to cancel those units so you know which one goes on the bottom. And you have to have a true and valid relationship. So we got one of them. You have to get the other. Does everybody know the conversion unit between cubic decimeters and liters? What is it? 1 cubic decimeter is 1 liter. Okay, does everybody know that relationship? Okay, so get that one. You guys get it? Okay, you know what units have to go on the bottom. You've got cubic kilometers on top. Guess what goes on the bottom? Cubic kilometers. And you've got this true and valid relationship. So you put that one in. Okay, so watch the road map. Watch your road map. You're going from cubic kilometers to cubic meters. You got that. And then from cubic meters to what? No. Cubic meters to what? Cubic decimeters. And then you got to go again from cubic decimeters to liters. Okay? All right. Did you put cubic kilometers on top? Did you put cubic kilometers on the bottom? Okay, what's that true and valid relationship? What did we say? 1 cubic kilometer is 1 times 10 to the 9th cubic meters. You get that? That was we got that conversion factor. Okay, good. Now you got to get the next conversion factor. Okay. So remember our conversion factors. Okay, we got that conversion factor. Now you need the next one, because you're going to have cubic kilometers on the bottom, cubic meters on the top. So I need another conversion factor with cubic meters. How am I going to get that? 1 meter is 10 decimeters.
Final answer. It's going to be this power. We do not. We have to multiply them, right? It's like all. Yeah. Okay.
Is that right?
Thank you.
And
Perfect.
is that right?
Yes, yay, you still got it. Awesome. Okay, keep going.
I'm trying to figure out how to.
Okay, so you see how, did you know how we get from here to there, right? We cubed it. So how are you going to go to here to a cube?
1,000 meters equals 1 kilogram.
Yeah, but no, because 1 meter is 10 decimeters. But we want to cube it. Just like we said, 1 kilometer is 1,000 meters, and we cubed it. So 1 meter is 10 decimeters, and now we cube it. So do you see how we did this one? And then we cubed it? Because we had 1 kilometer equals 1,000 meters. That's what we started with. And then we cubed it. And then this is how it looks. So now you have the same thing. So you have 1 meter equals 10 decimeters. Well, that's like what we did here. And we
So
cubed
then
it.
you just cube. Okay.
So now we're going to cube it.
Okay.
And then you know how to write out the cubes, right? So write out the cubes,
Okay.
except that doesn't go there. It's a cube. It's just meters times
okay,
meters times
yeah.
meters. That gives you meters cubed.
Okay.
Okay, now cube it out. And then that's going to be your next conversion factor.
Okay.
Good. Excuse me.
Sorry.
It's okay. How are we doing back here? Good? Making sense? Are we cubing it? Getting that other conversion factor?
Cubic meters,
Okay.
cubic decimeters.
So you're just gonna have to cube.
How are we doing back here? Are we getting it? Or are we lost? Completely lost.
I just want to know which one is greater unit, centimeter or decimeter? Decimeter, right?
1 meter has 10 decimeters.
And 1 meter has
100 centimeters.
And decimeter is bigger.
Decimeter is bigger than a centimeter. Yes.
You know, she's saying that centimeter is bigger and
Well, we're thinking bigger as in more of them. There's 100 of them in a meter.
I got it.
I guess it depends on how you want to look at bigger. Okay, so you got that right, and then you got to put cubic meters to cubic decimeters. Perfect. That's perfect.
Like what I do next? How do
Well, then you go to you got this one. So this is what the roadmap is for. So it tells us what to do next. You did this, you did this. Now we got to do this. So that's what you do next, is you do this one next. So that's why we use a roadmap to kind of tell us, because sometimes we're so working on the conversion rate, like, where was I going again? And this is what that's for.
Okay.
And then you have to think of a true and valid relationship between those two. Okay, good. All right, so keep going. What have you got? This word right here is what? Cubic meters. So guess what word you're going to put right down here? Yeah?
1 into 10 to the power 3 decimeter.
No, what's this word?
Meter cube.
Meters and decimeters, do they cancel out? No, that's the wrong one. So this isn't going to work.
So I have to put
What is that word? Cubic meters? Unit is cubic meters?
meter cube. Yeah.
So what are you going to put on the bottom? Meters
Meter
cubed.
cube.
Oh, well, here's meters cubed.
Yeah. So I
So you have to put meters cubed. You have to put meters cubed.
1 into 10 to the power 3 meter cube.
No. 1 times 10 to the 3 is cubic decimeters. You don't want cubic decimeters. Didn't we want cubic meters? So which one is the cubic meters? This is the cubic meters. So it's 1 cubic meter. It's 1 goes with the cubic meter. 1 times 10 to the 3 goes with the cubic decimeters. So we can't just like change it up, mix and match it. This is 1 cubic meter. So 1 cubic meter has to go on the bottom. So write 1 cubic meter. You see why we have to do that? It's because your units have to cancel. If you put cubic decimeters, they're not going to cancel. It's not going to work. So then what goes on top? This. 1 times 10 to the 3rd cubic decimeters. Cube, don't forget to put the cube there. Okay, then go again. Because you're almost there. Now you got to do the liters. You got to go from cubic decimeters to liters. So if I have the word cubic decimeters on top, guess what has to go on the bottom?
Meter. Meter cube.
No. What's this word?
Deci.
What is this?
Decimeter cube.
So what goes on the bottom?
Decimeter cube.
Yes. You see that? Okay. You didn't cube it. Has to be cubed. 1 meter cubed. So we had to write that conversion factor. So we say 1 meter is 10 decimeters. Then 1 meter cubed is 10 decimeters cubed. All right? So 1 cubic meter is equal to 10 times 10 times 10 cubic decimeters. Not that. See, you see how this is meters cubed? So you better have meters cubed.
Okay.
Well, 1 meter cubed does not equal 10 decimeters.
Okay.
1 meter cubed equals what? 1,000. 1,000 cubic decimeters, not 10, 1,000 cubic decimeters. You see how you have to have the true relationship? And the units have to match. That has to be cubed.
Cubed.
Yes. You see how these have to match. You don't have a choice.
Okay.
All right, so there's this word, cubic decimeter. So guess what has to be there? Cubic decimeters. Now you know what the relationship is, right? Remember that? We talked about 1 liter is 1 cubic decimeter, yeah? Uh-huh. Okay, does that make sense? Good. Awesome. Exactly. It just takes practice. Perfect. All right, so did we get the answer? Did you guys find the relationship between cubic meters and cubic decimeters, right? Yeah? Okay. You guys got that? Is this looking right? Okay, you know your units are canceling, right? So what do we get? What unit is that? Liters. Okay, did we come up with that? Everybody got it? That's how it looks? Make sense? Okay. You are watching it in your calculator, aren't you? Are you using that EE and the EXP button? Yeah, be very careful about that. Also, in your calculator, if you want to, if you're going to type this in, sometimes we have calculator issues, you can say this times this times this times this and write a number down. Then you say this times this times this and you write a number down at the bottom and then you divide the two. You can do that, fine. Or, you can put this top part in parentheses and you can say this times this times this times this in parentheses divided by, you have to put another parentheses to say this times this times this. Okay? Don't forget the parentheses. Okay, that's one way. Let me tell you another way. If you don't want to do, the parentheses thing, dividing the whole top and then parentheses and bottom parentheses, I like to do it this way. I like to say this number times this number divided by that number times this number divided by that number times this number divided by that number and just work my way down. And I don't have to do parentheses or write down what those numbers are. So that's an idea. Okay. Questions? All right. Okay, how are we doing? Good? Okay, do you guys have questions or are we good? We good? Yeah. All right, let's go on to the next one. Okay, this time, notice, when we did these, we never had anything under here? Yeah. Okay, well now we're going to put something under there. All right, so now we can do cubes. It's like, hey, let's add something else. Yay! All right. Let's talk about this one. Gosh, gas prices are falling like crazy, aren't they? Yeah. Gas prices went like crazy, rising. Remember, just up and down. Okay, well, the cost of gas has risen everywhere. In Japan, the cost of gas was 161 yen per liter in the summer of 2008. How much is that in dollars per gallon if the exchange rate was 108 yen per dollar? What's my starting unit that I'm working with? Yen per liter. And what am I trying to change that to? Dollars per gallon. Okay, so here we go. I've got 108 yen. Now, how am I going to write that? Yen per liter. Okay. It would be per liter, so I'm going to put 1 liter. That's per liter. So now we have something on the bottom. 1 liter. Okay, now what I want to do is convert that to dollars per... Oh, I'm sorry. 161. Ooh, good catch. 161 yen per liter. Okay. And then I'm going to change that. I'm going to convert that to dollars per gallon. So what we're doing is essentially two conversions. yen to dollars, and liters to gallon. So what it is two roadmaps. So I've got yen going to dollars, and then I've got liters going to gallons. All right, well, let's take yen to dollars. Do I have a true and valid relationship that gets me between yen and dollars? Yeah, what is it? Yeah, that's the 108 yen per dollar. Okay, that's my conversion factor here. 108 yen equals $1. Okay, well, what about the next one? Liters to gallon. We're like, how do we do that? Well, and you look in the back of your textbook and you find the conversion factor. That's true. We could say 1 gallon is 3.74. Let's just say we don't want to use that one. Let's just say we want to use the quarts one. Wouldn't that be more fun? Is there a quarts one? Liters to quarts?
1 liter is 1.0567.
Okay, let's do that one. But then do we know quarts to gallons? Does anybody know quarts to gallons? You guys know? Does everybody know that? 4 quarts is a gallon? You're like, no. Okay, that's kind of stuff will be given to you on the exam, but I just kind of want to use that just to throw in a little bit of English. All right, so how do we do that? English metric units there. All right, how do we do that? I've got yen on top. What goes on the bottom? So I'm gonna look at my conversion factor and I say, oh yeah, it's 108.0, and what is it on top? $1. Okay, yens cancel. I'm left with dollars. I'm getting there. Now I got to convert liters, so I can do it all in one chain. So if I've got liters, I need to cancel out the liters. So where am I going to put liters? We've always put it on the bottom. Why can't I put it on the bottom? They won't cancel. It'll be what? Liters times liters, and now we get liters squared? Okay, that's not going to work. So it has to go on top. So I can put liters on top, and then we're going to do quarts. So that's 1 liter is to 1.057 quarts. And then my liters cancel. And then I've got quarts on the bottom, so now what? Quarts on top. Why am I putting quarts on top? Don't these have to cancel? Yes. And then where do I want? I want gallons, right? So it's 1 gallon is 4 quarts. So the answer comes out to be $5.64 per gallon. And that's your answer. All right. Does that make sense? Okay. Whew. Well, that finishes up chapter 1. Oh boy, yay! Woo, all that dimensional analysis and sig figs, and we're going to be using that all the time. So I'm glad it's right there because we're going to be using it all the time. So these kinds of things we're going to be using every time. So when we get and we start doing other problems, we're going to use this stuff to solve those problems. So you got to really nail this stuff down. Okay, well, we're getting ready to start chapter 2. And this would be a good time for us to take a break, so we will come back in 15 minutes, and we'll do chapter 2. All right, so let's take a quick break.